Hi, geometry students. We are starting a new unit and it's on transformations. So this first day, we actually start with a little construction. So we kind of pick up right where we left off. So talking about reflections, when you think of reflection, most likely you think of like a mirror reflection, what you would see in the mirror. That is not untrue. It's the idea that, you should essentially see the same thing, just moved in a different location. Some vocab that you're going to want to recognize here, and feel free, you can highlight it if you have a highlighter. The pre-image, that's the original image. So the original thing that you're starting with. All right. So the original figure. The image, that's the shape that results from the transformation. So essentially it's like your answer, right? So I'm going to say the shape that results from the transformation there. In this case, we're starting with reflection or a flip. So reflection, it can be reflected over a line or a point. We're going to focus today on over a line to start, and then we'll talk about over a point in a little bit. So it's saying when you flip it across a line, it is called the line of reflection, such that the line of reflection is the perpendicular bisector. Right? So perpendicular bisector of each segment joining each point in its image. So from the pre-image to its image. So this first one, we get to do a little construction and it's connected right to that perpendicular bisector. So we're going to construct the line of reflection using our compass and straight edge. So if yours isn't nearby, pause the video, go grab it. The first thing that you're going to do is we're going to create the segments that join the pre-image A to the image A prime. So I'm going to connect those dots here. So I have A and A prime. Now I could have picked B and B prime, but might as well start at the beginning of the alphabet. All right. To do a perpendicular bisector, you're going to take your compass, you know this drill, put it on one of the endpoints, open it more than halfway. So kind of eyeball where that would be. For me, I'll say about here-ish, and I'm going to swipe my arc. All right, go over to the other endpoint. So I'm going over to A now, swiping that same arc, and then I'm going to connect the dots. So when I connect it, let me line this up here. This right here, that is my line of reflection. Now mine might be a little skewed. I don't know. Sometimes it's hard to tell, right? So could you connect B and B prime and construct it again to see if it falls in the same spot? Sure, absolutely, right? But what it means is if I were to take this original image and then flip it over that line, it should land over here. That's what we're looking at. So this is the, I might have misspoke. This over here is the pre-image. And then the answer, this is the image. If I said that backwards before, my apologies. All right, let's move on. So now you know how to construct the line of reflection. What about if it's given to us and we flip something over it? So I'm going to move on to this next page. Now, to save myself a little time, I already plotted the triangle. Yours is not on your paper. So if you need to pause the video and plot it, go ahead and do that. Otherwise, we're going to go right into this first transformation. It says the vertices of triangle M and P are given as 1, 2, 1, 4, and 3, 3. So remember, anytime you're plotting a point, it's X and then Y. So you're going over 1 and up 2 and plot that point. We want to draw a triangle M prime, N prime, P prime, which is going to be the image of this one after a reflection over the Y axis. I would encourage you, if you have another color, if you have a highlighter, I want to focus in on the line of reflection. So the reflection over the y-axis means I want you to highlight on your paper the y-axis. All right. Once you have it nice and highlighted, I want you to just visually be able to flip those points over the line. So I'm going to look at M, which starts at 1, 2. And then if I look at it, since you're going perpendicularly across, since this is a vertical line, we're going to go horizontal. So I go horizontal 1 to the line, which means I'm going to go equal distance or 1 past the line. That should be my M prime. That point is -1, 2. So plot it, label it, write it down. We're going to do the same thing with N. So n is starting at the point 1, 4. So use the visual. If I go 1 unit to the line, I'm going to go 1 unit past. So here's n prime, which is the point -1, 4. And then lastly, we can do the same thing with p. So it starts over here at 3, 3. So I have to go 1, 2, 3 units to the line. So I'm going to go 1, 2, 3 units past the line. That's going to be my p prime. And so that location is -3, 3. All right, go ahead and connect the dots, make it nice and pretty. I hope you have a straight edge nearby. Otherwise, do the best you can to make it look like nice straight lines here. They're pretty small segments, so you can probably freehand it pretty decently. So you might have already started to notice a pattern, but we'll talk about that in just a moment. Let's try the next one. We've got triangle ABC. Again, pause the video if you need to. Given by those points, draw A prime, B prime, C prime, the image of triangle ABC after a reflection over the origin. Right? If you remember the origin, that's the point 0, 0. So the 0, 0 right here, I'm going to highlight that point so that I can kind of remember what's going on. All right. How you do this, to walk a point and flip it through a point like the origin, you almost essentially are going to take advantage of the slope here. So what I mean by that, if I start with A, which is over at -2, 3, and I want it to move to A prime, well, you have to figure out how far do you have to go to get to the point of reflection. So in this case, I can walk down 1, 2, 3, and over 2 to get to that point. So I'm going to repeat that same thing again. I'm going to go 1, 2, 3 down and over 2 past the point, and that's where A prime should land. So if I were to kind of connect them, I'm going to use a little dotted line here. You can see that that point ends up being the midpoint of the segment that connects from A to A prime. So where does A prime land? Well, this is 2, and that's -3 right there. So let's play that game again. If we take point B, which starts at the point -5, 2, count out the slope. So you're going to go down 2 and over 5. So I'm going to repeat that. Down 2 and over 1, 2, 3, 4, 5. That's where B prime should land. So we haven't talked about slope yet this year, but I bet you can remember it from last year. So that lands at the point 5, -2. All right, and then the last one, C, it starts at the point -4, 7. So where's it going to land? Well, I'm going to have to come down 7 and then over 4. So I'm going to repeat that. If I go down 7, excuse me, so I'm down to here and then over 1, 2, 3, 4, there's going to be my C prime. And again, if you want, you can draw that dotted line in. If you don't want to have to draw it in, you don't necessarily have to. It starts to get a little messy after a while, but connect the dots. And so we are just simply using kind of our visual at this point. We haven't talked about any rules yet, but you might start to see the pattern again. So here we're at the point 4, -7. So when you look at all those numbers, do we start seeing like what's happening each time? Is there a connection? So hold on to those thoughts. We're going to put them onto the next page. So let's move on to number 3. Number 3 says we've got the vertices of a trapezoid here. So D, E, F, G. So trapezoid, one side's parallel, one side is not. All right. Draw the trapezoid, which I already did, and the image of the trapezoid after a reflection over the line y equals x. Okay, the line y equals x. Think back to your basic old y equals mx plus b. So the number in front, that's your slope. The number back, that's your y-intercept. So if all I have is y equals x, that means my slope is 1. My y-intercept is 0. So you're starting at 0, and then you're counting up 1, right 1, up 1, right 1, and so on. It's that perfect diagonal line. So grab your straight edge, draw it in. Even though I'm using pen, it's mostly so you can see better. I would always suggest on a graph using pencil. This way, in case you make any mistakes, these are things we can fix. All right, since it's what I'm reflecting over, I'm going to highlight it to remind myself that that's what we're reflecting over here. So once you flip over it, whoops, sorry, get my hand out of the way there. Or excuse me, once we draw it, now we can flip over it. Now what you have to think of is, it is that perfect diagonal slanted to the right. So when I flip my points over it, I have to go the diagonal going the opposite direction. So instead of from like bottom left corner to top right corner here, I'm going to go bottom right to top left of any of like the little boxes on the graph, if you will. So for D, I'm going to hop this little square from one corner to the other, and then I'm going to go one more. So that's where D prime should land. Right? So that means D, which starts at 2, 0, lands at D prime, which right here is 0, 2. Okay. E, if you notice, E is on the line. So when you flip it over, it doesn't actually move anywhere. So E is going to stay exactly where it is. We're going to talk about that vocab term later, but that's called invariant, meaning it doesn't move or it doesn't vary at all. So it stays at 2, 2. All right. If we take F, so F right here is at 5, 2. And let's carefully walk it across that line. So I'm going from this corner to the next and then halfway. So I'm going to go halfway and then one more corner. Here's where F prime should land. And so that is the point 2, 5. And then lastly, we've got G at 5, 1. All right, let's see if we can play that same game. You're going corner to corner. So I'm going bottom right to top left, and I do that twice. So let's go twice past it. So 1, 2. That's where G should land. Or G prime, excuse me. So G prime is the point 1, 1, 2, 3, 4, 5. Now take a look at those numbers. 2, 0 to 0, 2. This one stayed the same. 5, 2 to 2, 5. 5, 1 to 1, 5. I bet you're starting to figure out exactly what that rule is here. But let's connect the dots so that we can actually see the diagram. These are tiny little figures, which sometimes makes it a little bit tough to see, but we'll make this work here. Okay. So it's sort of the same figure, but when you flip it over at a diagonal, it kind of flips the positioning of it a bit. All right. So let's look at the rules. So we have rules that we want to be able to create based on what we've seen for flipping over the x-axis, y-axis, origin, and the line y equals x. Now, something to notice already, when you're looking at reflection rules, we're using a little lowercase r, and then in the subscript, we're writing down, what we're reflecting over. So for reflection itself, we're going to use that little r, and then down in the subscript, so kind of down below, this is going to tell you what we are flipping over. So let's go back. I'm going to pull back that first one. With the first one, actually, I take it back. The very first one, we flipped over the y-axis. So take a look at those values. It went from 1, 2 to negative 1, 2, 1, 4 to negative 1, 4, 3, 3 to negative 3, 3. So in general, what's happening, we're taking x, y. The y is not changing. The x just flips to the opposite sign. So it goes to negative x, y. So that's the rule for flipping over the y-axis. Let's go write that down. So it's going to go to negative x, y. For the origin, all right, that was the second example. So for this, we went negative 2, 3 to positive 2, negative 3. Then negative 5, 2 to positive 5, negative 2. Negative 4, 7 to positive 4, negative 7. So what we should be seeing here, it's a little bit trickier, but the signs are just switching. So the x switches sign, the y switches sign. So when you're reflecting over the origin, xy goes to negative x, negative y. All right. And then the last one that we did was flipping over the line y equals x. We just looked at that one a second ago. That one's pretty easy to spot. They literally switch places. So xy ends up going to y, x, just like that. So this is going to go to yx. All right, now something to keep in mind. We didn't actually do the top one, but let's take a look. If we were to kind of do it generically, I'm going to give myself a little set of x, y axes here. Right? If I take a point, I'm going to start over here in the positive quadrant. So quadrant 1, that is. If I take a generic xy point and I flip it over the x-axis, it would land down here. Well, think about what's changed. I still went over the same x distance, but instead of it being a positive y, you're going down. It would be a negative y. So this one, the x would stay the same. The y would change. So you kind of end up with the reverse relationship from here. Now, as for the rules, it's up to you if you want to choose to memorize them. I'm a really visual person. It makes more sense for me to draw it and take a look at it than it does to try to memorize this. So it's your discretion, but something has to work. So you have to either be able to look and say, hey, if I flip over the y-axis, the x gets negated, the y stays the same, and so on. Right? The one I will say that I think is worth kind of memorizing is this one, just because sometimes it's a little tricky to see it otherwise. That's the flipping over the line y equals x. But take it or leave it. That's my suggestion. All right, let's see if you can either use the rules or envision what's going on for each of these. So it says state the image of each point after the following transformation. You're flipping over the x-axis, this first one. So if I use the rule, since I know some people like the rule, looking up top, when you flip over the x-axis, x is going to stay the same, and just the y changes sign. So you'd keep -4, and that's going to flip to a +3. For the second one here, when you flip over the origin or you reflect through the origin, both the x and the y are going to negate. So this becomes -3 and then +7. For number 3, if we're reflecting over the y-axis, it's the x value that changes. So we negate x and we keep y. And then the last one, a little different from the others. We don't negate a darn thing. When you flip over the line y equals x, literally the y and the x trade spots. And so we end up with the 0.53. All right, with that being said, we have a little bit of practice on the next page. There's some multiple choice questions that have been taken from an old Regents exam, I believe here. So when it says multiple choice, the graphs shown are two congruent triangles, triangle ABC and triangle A prime, B prime, C prime. In case it's hard to see, this one has the little primes on it. It says which rigid motion. So rigid motion is an idea of a translation, a rotation, a reflection. And we'll talk about all of those transformations soon enough. But it says which rigid motion would map triangle ABC on to triangle A prime, B prime, C prime. Well, given what we're talking about today, that's your first hint. All right. But if you look at the orientation of what's going on and think, all right, for A to go to A prime and C to go to C prime and B to go to B prime, I could actually do a little construction here. And the construction I would end up with would be the perpendicular bisector of all of those, forming this line right here. And that is the line y equals x. And now without even doing all the other ones, a rotation would require seeing that picture spin. And so it's not spinning over, which means we could get rid of the two rotations. Translations we will talk about soon enough. The idea of kind of just shifting and sliding a graph. Right? So with that being said, you have one last question here. It's saying you've got a square graphed here, a reflection over which line does not carry the square onto itself. All right. So what that means is if you were to flip over that line, it wouldn't match on what it does already. So as an example, right, if I take, let's take this last one. If I take that move x plus 4, if I draw that line in here, negative x plus 4, I would start at a y-intercept of 4. So 1, 2, 3, 4. And then the slope would be -1. So I'd count down 1, right 1, down 1, right 1, and so on. So if I draw that line in here, I would get this. This is the line, y equals negative x plus 4. If I reflect that square over the line, what you're going to notice is this point would come 1, 2, 3 to hit the line and go 1, 2, 3 past. It would still land on itself. So even if you fold over, it will match perfectly. So when it says which reflection over, or excuse me, the reflection over which line does not carry the square onto itself, you have to figure out which one, if you were to fold it or flip it over that line, however you want to think about it, would not land already on itself. I want you guys to try this one, and that's going to be part of your post video question. So I've already determined the answer can't be 4. So I want to know, of the remaining ones, is your answer 1, 2, or 3? All right, thanks guys. Have a good one.